0, what do we know? If delta G is greater than 0, what do we know? It's spontaneous in reverse.
So it's non-spontaneous.
So it's non-spontaneous as written. Forward. What if delta G equals 0?
It's equilibrium.
Then we are at equilibrium. Okay? We have a new equation. And it's on your bestie. Okay. First, let's make sure we understand this. What's the not mean?
At standard room temperature.
Standard conditions.
Yeah.
So, what's standard temperature?
25 degrees Celsius.
25 degrees Celsius or
298 K.
298 K. Okay, if we're dealing with gases, then there'll be 1 atmosphere. The partial pressures of all the gases involved will be 1 atmosphere. If we're dealing with concentrations, there'll be 1 molar. Okay? So delta G naught is calculated. All those tables that you've been working with are calculated at standard conditions. Sometimes we're not going to be at standard conditions, so it'll just be delta G. Okay? So delta G, we want to solve for it, and we do. Delta G equals delta G naught plus RT natural log of Q. What do you suppose R is?
A constant.
Gas constant. Is it on there?
Yeah.
And T? Temperature in Kelvin. What was Q?
The reaction quotient.
The reaction quotient. What does that mean?
K.
It's not K.
Oh.
We solve for it the same as K, but what is Q? When did we solve for the reaction quotient?
When you precipitate. No.
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 When we're not at equilibrium.
Oh yeah.
Okay, we did it. Remember we were on equilibrium for like 6 months? We solved for Q to see, predict, and then compared it to K to see which way the reaction would shift to reach equilibrium.
Yeah.
Oops. Okay, R is the gas constant. That's on your bestie. 8.314 joules per mole Kelvin. T is the absolute temperature. Q is the reaction quotient. So at equilibrium, delta G would equal 0. We just established that, right? We learned that last week. Also, at equilibrium, Q would be equal to K, which means it's not going to shift to reach K. You're already at it. So if we're at equilibrium, we can set the equation to 0. Because delta G would be equal to 0. And 0 would be equal to all this. So delta G naught would be equal to negative RT natural log of K. See what we just did there?
Yeah.
Okay. Why are we doing this? Should have one more line on there. What? Huh? How did I skip so far ahead?
Starting equilibrium.
You and I could probably do this one.
No way.
Do you want me to be your clicking person?
You know how to click the girl?
I think I do.
Where was I here?
I was clicking
Yeah.
girl last year.
Okay.
You want to put it this way?
Basically, there's a relationship between delta G and K. And if we know all of this, we can solve for K. Write this down. Right underneath that. I should add it to the PowerPoint.
A is equal to L.
Natural log. Yeah, NaN, natural log. Probably can't see it on the video. Can you? Where'd my eraser go?
Here you go.
Oh, it's on the floor. Thanks, Ryan, for knocking it off the floor.
You're welcome. Wait.
So K is equal to, what's E? No. Is that rain?
No, I think it's not. Oh,
Rain, isn't it?
there was no rain in the forecast.
Yes, it was.
Oh my God,
It was 110%.
there was like a 5%.
On my Android phone, it said a chance of rain. Is your iPhone telling you something inaccurate?
No, I didn't even check my phone. I checked the other channel. No other channel.
What's E?
E is anti-law. No,
Anti-natural log.
there you go.
We're solving for K, so we got to undo this. So we've just rearranged this so we can solve for K. Is that on your bestie? Got your bestie. Can't remember. If it's not, then we need to be able to manipulate it ourselves. Get out your bestie.
Here.
It's not, is it? Huh? The first one's on there. Nope. That's electrochem. Okay. Somewhere in your notes, have some practice problems. I got them written on the board. One, calculate delta G naught for the following reaction. And we are gas. Okay? So you can use your, let's do it the easy way. Use your thermochemical data table using the delta G formation. Solve for the delta G naught for formation of ammonia. Can you see the problem?
Yeah.
All of the really exciting entropy videos are on the website now. It's a balloon. Yeah. You forget how your refrigerator works. In case one day you get a refrigerator. Huh? Yeah. Got an answer for delta G naught for me?
Yeah.
Is anybody doing the problem?
I'm seeing it.
I'm setting it up. Excuse me? Get your four straight? Good. Let's character.
I learned how powerful
Thought you were doing time.
yeah, that just carved it out.
All right, that's a good way to learn.
185.1.
No, What'd you get?
25.1.
No, over here, the right answer.
Wait, that's for number one?
I didn't do anything.
Negative what? Units? Kilojoules?
Yeah, totally with that.
How come no one else can get that? I got the same thing.
What's the answer?
What seems to be the problem? I thought we had this formula down.
We do.
Products minus reactants.
Wait.
And
I didn't get it.
what's the delta G for an element in its most stable form?
0.
0. So this should be easy, right? Just take the delta G for NH3. What is that? 16.4 multiplied by 2. Subtract 0. Twice. Can we move on now?
What the nickel point is.
Yes.
Tell me where the two people know how to do this.
I know how to do it.
I know how to do it.
Leslie knows how to do it. She ain't been here in a month.
Okay, well, she does. He does. Mona says she does. That's 3 people. 1 and 2. Let's move on.
Okay. Calculate delta G, no not, meaning not at standard conditions, if you have 1 atmosphere of N2, 3 atmospheres of H2, and 0.5 atmospheres of NH3. All right, this is going back a ways. We've done acid-base equilibria. Remember way back in the day when I first started equilibrium, we did Kc and we did Kp. What did Kp use?
Pressure.
Partial pressures. So we've got partial pressures for the gases involved.
We solve Q using partial pressure.
Yes. We
Oh,
solve
got
for
it.
Q using the partial pressures.
Mm-hmm.
Okay? Then we're going to plug it into this equation.
Okay, got it.
Okay? So delta G equals delta G naught, which we just solved for in the first question, plus RT natural log Q.
Wasn't it temperature?
Where did I get that question? Temperature is, we're still at standard temperature, so 298. There. Does that help? Okay, so how do I solve for Q?
Equilibrium expression, I think.
Equilibrium expression is
NH3 squared. P, yeah. P, yeah. Over,
let's write it this way. P NH3
yeah.
Yeah.
over
N2
P
of N2
N2
times
P
H2 cubed.
H2 cubed. Okay? So the partial pressure of the ammonia is 0.5?
Yeah.
Over the N2 was 1,
Yeah.
and the H2
27.
is 3 cubed. So what's cubed?
I got
9.5.
what?
Oh, that's squared. All right.
I got 9.26 to a negative third.
27.
Which are right there. Q equals 9.26 times 10 to the negative third.
Yeah.
Okay. We have independent confirmation of that number.
Let me restart.